Hey everyone, and welcome to Something with Joe. In the previous videos, we discussed the mole, and how the mole can be used to signify the amount of a substance. We also spoke about how the mole relates to mass, which led us to practicing some mole calculations using mass and some mass calculations using moles. Now in this video, we are going to be going through some more mass and mole calculations, only this time there will be an additional step. That additional step will involve cancelling out the units we don't want for our answers using conversion factors. The unit we don't want for our answer is the unit used to express the value we are converting from. So for mass calculations that would be the amount in moles and the unit would be moles, whereas for mole calculations that would be mass and the unit would be grams. The use of conversion factors to cancel out units we don't want for our answers can be used in some exams. However, the requirements of different exams vary. I would advise you seek advice from your teacher, your tutor or your lecturer on whether to use conversion factors to cancel out units for mole and mass calculations in your exams. If you find that you don't need to use conversion factors for mole and mass calculations in your exams, then please refer to the previous videos in the channel, links to which I'll leave down below. Also, the following calculations will only involve the variable molar mass rather than the variable relative formula mass. The reason for this is that relative formula mass doesn't have any units. So if you want to see how mass and mole calculations can be done using relative formula mass, then please refer to the first video in the channel, link to which I'll leave down below. Okay, firstly, let's look at what a conversion factor actually is. A conversion factor is a fraction that consists of two equivalent values with different units. So you have one value with a particular unit as a numerator and an equivalent value with a different unit as a denominator. Now the main purpose of a conversion factor is to allow for the conversion between a measurement featuring one unit to a measurement featuring a different unit. This is achieved in a calculation by cancelling out the unit we want to convert from, thereby only leaving the unit we want to convert to for our answer. Let's see how this happens with an example that doesn't feature the mass or moles of a chemical substance first. In this example, we are trying to convert from a measurement in feet to a measurement in inches. Now to convert from a measurement in feet to a measurement in inches, we want to cancel the unit of feet from this calculation. To do this, we have included a conversion factor that has 12 inches as the numerator and the equivalent value of 1 foot as the denominator, because there are 12 inches in 1 foot. The inclusion of this conversion factor means we now have the unit of feet at the top and the bottom. This now means we can cancel out the unit of feet as follows. This then allows us to carry out the calculation, but only with the unit that we want for our answer, which in this calculation is inches. So 5 times 12 inches divided by 1, and we get an answer of 60 inches. As you can see, dividing by 1 doesn't change the numerical value of the answer, because we do 5 times 12 equals 60, 5 times 12 divided by 1, the answer is still 60. The only reason why that 1 was included is because it allowed us to include that equivalent value to set up that conversion factor to cancel out that unit of feet. Okay, let's carry out a calculation in which we use the mass of a substance to work out the amount of a substance in moles using a conversion factor. Let's have a look at this question. How many moles of molecules are there in 60.8 grams of nitrogen dioxide? Now the first thing we have to do is consider the formula we're going to use for this question. And the formula we're going to use is this one. Amount in moles equals mass in grams divided by molar mass, which is given as grams per mole. Now the molar mass is the mass of 1 mole of a chemical substance, and it is this that we must figure out first. Okay, so what is the molar mass of nitrogen dioxide? Well, to work that out, we must consider the relative atomic masses of nitrogen and oxygen. So, according to the chemical formula of nitrogen dioxide, we have 1 nitrogen and 2 oxygens. So to work out the molar mass of nitrogen dioxide, we must do the following. M, which is the symbol we use for molar mass, equals the relative atomic mass of 1 nitrogen, which is 14.0, plus 2 times the relative atomic mass of oxygen, which is 16.0, and then that gives us a molar mass of nitrogen dioxide of 46.0 grams per mole. Okay, so now we know the molar mass of nitrogen dioxide, we now have to organise the calculation, so we include a conversion factor that will allow us to cancel out the unit we don't want for our answer, which in this case is grams. So, to do this, we must take the mass of the sample of the substance, which is 60.8 grams, and that is of nitrogen dioxide, by multiplication sign, Draw a line, and then for our conversion factor, the denominator will be the molar mass of nitrogen dioxide, which is 46.0 grams of nitrogen dioxide, and the numerator of our conversion factor will be the equivalent value to the molar mass of nitrogen dioxide, and the equivalent value is 1 mole of nitrogen dioxide, because the molar mass is the mass of 1 mole of the chemical substance. Therefore, the equivalent value will be 1 mole of nitrogen dioxide. Okay, so now that we've included this conversion factor, we now have the unit of grams of nitrogen dioxide at the top and the bottom, which means we can now cancel out that unit as follows. And then we are only left with the unit we want for our answer, which is moles of nitrogen dioxide. So now we can carry out the calculation. So 60.8 times 1 divided by 46.0, and then we're going to give an answer to 3 significant figures. Now the reason why we're doing this is so we can give an answer with the same number of significant figures that are in the value in the question with the fewest significant figures. Now you may note that the equivalent value contains 1, which is 1 significant figure. However, we don't consider this when we decide how many significant figures should be in our answer. We just look at the other 2 values, and as you can see, 60.8, 3 significant figures, 46.0, 3 significant figures. So our final answer will be the 3 significant figures, and that answer will be 1.32 moles of nitrogen dioxide. Okay, let's have a look at another mole calculation. Only this time, instead of working out the number of moles of a compound present in a sample, we are asked to work out the number of moles of a particular ion present in a sample containing an ionic compound. Let's look at the question. How many moles of nitrate ions are there in 70.8 grams of lead nitrate? Now the first thing we're going to do is figure out what formula we're going to use to work out the number of moles of lead nitrate in the sample. And the formula we're going to use is the same formula we used for the previous calculation, which is where we work out the amount in moles by dividing the mass in grams by the molar mass. So the first thing we're going to do is work out the molar mass of lead nitrate. Okay, so to work out the molar mass of lead nitrate, we must look at the chemical formula for lead nitrate, which indicates that in each formula unit of lead nitrate, there is 1 lead, 2 nitrogens and 6 oxygens, because this 2 on the outside of the brackets indicates that everything inside the brackets must be multiplied by 2. So we have 1 lead, 2 nitrogens and 6 oxygens. So to work out the molar mass of lead nitrate, we must do the following. We're going to write M, which is a symbol for molar mass. We take the relative atomic mass of lead, because don't forget, even though we are calculating the molar mass of a ionic compound which consists of ions, we still have to consider the relative atomic masses of the elements present in the compound. So the relative atomic mass of lead is 207, and we only have one of those, so we have just 207, and then we add to that 2 times the relative atomic mass of nitrogen, which is 14.0. Then we add to that 6 times the relative atomic mass of oxygen, which is 16.0, and then we get a total molar mass of lead nitrate of 331 grams per mole. Okay, so now we know the molar mass of lead nitrate. The next thing we can do is organise this part of the calculation to include a conversion factor that will allow us to cancel out the unit we don't want for our answer to this part of the calculation. Now to do this, we take the mass of the sample of the substance, which is 70.8 grams of lead nitrate, and then we multiply that by a conversion factor that consists of the molar mass of lead nitrate, which is 331 grams of lead nitrate, and an equivalent value of 1 mole of lead nitrate, because don't forget the molar mass is the mass of 1 mole of the substance, therefore the equivalent value is 1 mole of lead nitrate. So now we can cancel out the unit of grams of lead nitrate as follows, because it is at the top and the bottom. And now we can calculate the number of moles of lead nitrate present in the sample. So 70.8 times 1 divided by 331, and we're going to give an answer to 4 significant figures. Now the reason why we're going to give this answer for this part of the calculation to 4 significant figures is because this isn't the final answer to the question, and we want to avoid the situation where we round too few significant figures too early in the calculation, so as to avoid inaccuracies later on when we come to working out the final answer. So the answer to this part of the calculation will be the 4 significant figures, and that answer is 0.2139 moles of lead nitrate. Okay, so now we know the number of moles of lead nitrate present in the sample, we can now work out the number of moles of nitrate ions present. Now to do this, firstly we need to consider the chemical formula of lead nitrate again, because as well as indicating the number of lead ions and nitrate ions present in one formula unit of lead nitrate, which is 1 lead ion and 2 nitrate ions, it also indicates the number of moles of lead ions and the number of moles of nitrate ions present in 1 mole of lead nitrate, which is 1 mole of lead ions and 2 moles of nitrate ions. And it is this information that we must now use to work out the number of moles of nitrate ions present in the sample. So to work out the number of moles of nitrate ions present in the sample, we must take the number of moles of lead nitrate present in the sample, which is 0.2139 moles, and then we must multiply that by the number of moles of nitrate ions present in 1 mole of lead nitrate, which according to the chemical formula is 2 moles of nitrate ions. Now what you may notice about this conversion factor is that the equivalent value, which is 1 mole of lead nitrate, because there are 2 moles of nitrate ions present in 1 mole of lead nitrate, that equivalent value is a part of the denominator rather than the numerator, as was the case in the previous calculations. Now the reason why this is the case is because we want to multiply that value of the number of moles of lead nitrate by the number of moles of nitrate ions. So the number of moles of nitrate ions present in 1 mole of lead nitrate must be part of the numerator, so as to allow us now to cancel out that unit of moles of lead nitrate as follows. So then we're only left with the unit of moles of nitrate ions, which is the unit we want to use for our answer. Okay, so we can carry out this calculation now. So 0.2139 times 2 moles of nitrate ions divided by 1, and we're going to give our answer 3 significant figures, which is 0.428 moles of nitrate ions. Now what you will notice is that the number of moles of nitrate ions is approximately twice the number of moles of lead nitrate present in the sample. Now this makes sense because if in 1 mole of lead nitrate you will need 2 moles of nitrate ions. So for whatever number of moles of lead nitrate you have in the sample, you will need approximately twice the number of moles of nitrate ions. So these values make sense. Okay. Let's now go through another way of doing that previous calculation, only this time instead of breaking it down into 2 separate steps, we're going to do it as one whole calculation, and we're going to write it out as one whole calculation. Now the way this works is that we take the mass of the sample of the substance, which is 70.8 grams of lead nitrate, and then after that we put the 2 conversion factors that we need to this calculation. So we have the molar mass of lead nitrate, 331 grams, and we have the equivalent value of 1 mole of lead nitrate. And then after that we have the number of moles of nitrate ions present in 1 mole of lead nitrate, which is 2 moles of nitrate ions, and the equivalent value of that, which is 1 mole of lead nitrate. Now the way this works is we can now cancel out the units we don't want for our answer as follows. We can cancel out the grams of lead nitrate, there and there, and moles of lead nitrate, there and there. So we are now only left with the unit that we want for our answer, which is of moles of nitrate ions. So we carry out the calculation again. So 70.8 times 1 times 2 divided by 331 times 1, and then we get an answer which we're going to give the 3 significant figures once again, which is 0.428 moles of nitrate ions. Now this way it's a very sort of neat and well organised way of carrying out the calculation. However, you've got to make sure that the values for each of these conversion factors are essentially in the right place in order for us to cancel out these units. Otherwise we won't be able to cancel out the units and we won't be left with the unit we want for our answer. So this method is a good way of doing the calculation. It saves us writing out 2 separate steps. However, you've got to make sure that the values are in the right place in order for these units to be cancelled out properly. Okay, so for the final question in this video, we're going to be calculating the mass of a sample of a chemical substance. Let's have a look at the question. What is the mass of 2.50 moles of potassium iodide? Now the first thing we have to do is consider what formula we're going to use for this calculation. And the formula we're going to use is this one, where we calculate the mass of the sample of the chemical substance in grams by multiplying the amount in moles of the chemical substance by the molar mass of the chemical substance. So the first thing we have to do, as we did in the previous calculations, is work out the molar mass of the chemical substance involved, which this time is potassium iodide. So we do that by considering the chemical formula of potassium iodide, which states that we have 1 potassium and 1 iodine. So to work out the molar mass of potassium iodide, we must do the following. M, symbol for molar mass, equals the relative atomic mass of 1 potassium, which is 39.1, plus the relative atomic mass of 1 iodine, which is 127, and then we get a molar mass of 166.1 grams per mole. Okay, so now we know the molar mass of potassium iodide, we can now organise this calculation to include a conversion factor that will allow us to cancel out the unit we don't want for our answer, which this time is of moles of potassium iodide. So to do that, we must take the amount in moles of potassium iodide present in the sample, which is 2.50 moles of potassium iodide, and then we must multiply that by a conversion factor that consists of the molar mass of potassium iodide, which is 166.1 grams, as the numerator, and as the denominator we have the equivalent value of that, which is 1 mole of potassium iodide, because the molar mass is the mass of 1 mole of the substance. Now you may notice that the molar mass is part of the numerator rather than the denominator, as was the case in the previous calculations. Now the reason for this is twofold. One, we must have the molar mass at the top of the conversion factor to allow it to be multiplied by the amount in moles as dictated by the formula, but also we want the equivalent value, which is a 1 mole of potassium iodide, on the bottom of the conversion factor, so we can now cancel out the units of moles of potassium iodide as follows, to then allow us to then only have the unit of grams of potassium iodide left to include in our answer to the question. So now we can carry out the calculation and give an answer to 3 significant figures, which is going to be the mass of potassium iodide present in the sample. So 2.50 times 166.1 grams of potassium iodide divided by 1, and we get an answer to 3 significant figures of 415 grams of potassium iodide. Okay, so there we go. We have calculated the amount of a substance in moles and the mass of a substance using conversion factors to cancel out units. I hope you enjoyed this video and found it helpful. If you did, please give it a thumbs up and don't forget to subscribe. Thank you for watching, and I'll see you next time.